Now that we have seen the marginal revenue curve for the monopolist, we are ready to study the profit maximization by a monopolistic firm. Just like what we have done in Chapter 7, to maximize the profit, we can set the first-order derivative of profit with respect to the quantity to 0. Again, the profit is the difference between the revenue and cost. So the first-order condition for profit maximization gives us the marginal revenue equal to marginal cost, or say marginal revenue minus marginal cost should be 0. That's the first-order condition for the profit maximization. In the previous picture, we have seen that the marginal revenue here is 24 minus 2Q for this demand curve, P equal to 24 minus Q. This is the same picture of the demand curve and the marginal revenue curve again, but now we have this short-run cost function. This short-run cost function gives us this average cost curve. You use this cost function divided by Q, and the average variable cost curve. The variable cost depends only on Q, so it's the Q squared. The Q squared divided by Q, which gives us the average variable cost, is just Q. So that's why it starts from 0 and is a gradient with a slope of 1. The marginal cost curve is 2Q. All we have to do is differentiate this cost function with respect to Q. The first term is not a function of Q. It doesn't involve Q, so it drops out. And the second term is Q squared. Again, we move the power to the front times Q to the first power, the 2 minus 1th power. To put them together, we have 24 minus 2Q, which is the marginal revenue, equal to 2Q, which is the marginal cost. And then all we have to do is plus 2Q on both sides of this equation. Then we have 24 equal to 4Q. Or say I moved this minus 2Q to the right-hand side of the equation. It becomes another 2 positive Q on the right-hand side. So we have 24 equal to 4Q. And the Q star, the profit maximizing quantity, is 6. That is 24 divided by 4. After we have decided this profit maximizing quantity, where the marginal revenue meet the marginal cost at the quantity 6 units of output. After we have calculated this profit maximizing quantity, we can put it back to the demand curve, shoot it back upward to the demand curve to see what is the market price. Remember, because this is a single demand curve, once you determine how much quantity you would like to supply to the market, there will be a price corresponding to that quantity supplied. So when we bring Q star equals Q back to this inverse demand function, we have 24 minus 6. We have a price of 18 in the market. That is the profit maximization decision. Now think about the shutdown decision. We have to tell whether the monopolist is making money or losing money. And if the monopolist is losing money, the monopolist probably will shut down. If it is not, it will keep operating. Again, the benchmark is actually still the average variable cost. If the price is below the average variable cost, then the monopolist should shut down. So let's look at what is the average variable cost. In this cost function, the fixed cost is 12 because it doesn't depend on the output quantity. The variable cost is Q squared because it will increase as the output quantity increases. Then the average variable cost is the variable cost Q squared divided by Q. Q squared divided by Q is just a Q. Q is 6, so the average variable cost is 6. 6 is less than 18, and we can clearly see that this price level is way above the average variable cost point here. So the monopolist does not shut down. Now let's look at whether the monopolist is making a profit. For the profit, we need to look at the average cost. That will include the fixed cost. So the average cost is the total cost divided by Q. That is the fixed cost $12 divided by Q plus the average variable cost, which is 6 for 6 units of output. So we have 6, the ABC plus AFC, which is $2. 6 plus $2 equal to $8. $8 is less than the $18 price. The average cost is $8. The price is $18. So the monopolist is making a $10 margin on the output per unit. So the monopoly makes a profit. Before we move to the next topic, I want to emphasize it again that the order of obtaining the results in the profit maximization for a monopolistic firm. The first number we get is from the profit maximization condition marginal revenue equal to marginal cost. That gives us the profit maximizing quantity. And it is from this quantity we put it back to the inverse demand function to get the price. So in this picture, we have the marginal revenue meet the marginal cost at this point, and that tells us this profit maximizing quantity. It is this quantity going back to the demand curve tells us what the price is. So if there is a question ask you about what's the price a monopolist will charge for profit maximization, you need to calculate the quantity first and then get back to the demand curve to get the price. Now I would like to do a little bit of comparison between this profit maximization and the profit maximization we have seen before for a firm in perfect competition. For both firms, there is this marginal cost curve. Basically, we assume marginal cost is rising. For a firm in perfect competition, the marginal revenue curve is flat, as we have reviewed, and the firm decides how much to produce for profit maximization at the point where marginal cost meet the marginal revenue curve, this point E here. The only difference here is that for the monopolist, the marginal revenue curve is downward sloping from top here. So instead of the flat curve, this marginal revenue curve slopes downward, and still the profit is maximized at where it meets the marginal cost curve. So let's review it again. When the marginal revenue is above the marginal cost, the difference between the two will be the marginal profit. As long as you have marginal profit that is positive, you keep produce more until the marginal profit is 0, when the marginal revenue equal to marginal cost. So the profit keep rising as the monopolist produce more and more until it hit the peak. Beyond that quantity, we can see that marginal cost here exceeds marginal revenue for the units above 6 units. And that is actually negative marginal profit. So that will chip in to the total profit here, make it decline. The story is the same here. Before the quantity of 284 units, you have marginal revenue above marginal cost. Then the marginal profit is positive until it hits 0, so your total profit keeps rising until this point. And beyond 284 units, you have marginal cost above marginal revenue. The marginal profit is negative, so that decrease the total profit if the firm keeps producing above 284 units. So the essence of the profit maximization problem for both kind of firms is the same. The only difference is the shape of the marginal revenue curve. In this picture, what we are looking at is the idea of supply curve. We have a pretty well-defined supply curve concept for firms in competitive markets, or say for the competitive market, there is a supply curve that is upward sloping as long as the marginal cost, either in the short run or in the long run, that marginal cost is upward sloping. So if at a certain price the market needs more quantity, the suppliers can produce more quantity and charge a higher price if we have this upward sloping market supply curve. However, in the monopoly market, there is basically no such concept as a supply curve because we don't really have a shape for it. It may just be a couple of dots for what we can observe. If one demand curve takes a certain position and a certain shape, for example, this D1 kind of flat, and it has a marginal revenue curve 1, it meets the marginal cost curve at this quantity and give you P1 price. And then for another demand curve have a different shape, it has a different slope and it intersects with the price and the quantity at different level than D1, but turns out its marginal revenue curve hit the marginal cost curve for the monopolist at the exact same quantity. And then when you project this quantity onto the D2 demand curve, you have a higher price. So that actually gives us a higher price in the market, but simply same quantity produced in the monopoly market. It can also be the case you have a third demand curve, the optimal quantity may be at a higher level and a lower price, or for a fourth demand curve, we have output quantity that is at a lower level and a higher price. So there's no clearly defined so-called supply curve in the monopoly market. It's always the case the monopolist observing the demand curve, see what is the marginal revenue he can get, and try to set an output quantity that make the marginal revenue equal to its marginal cost. So that's the difference in supply curve between the perfect competition and a monopoly market. Earlier in this video, we have derived a relationship between the marginal revenue and the elasticity. Remember, this relationship tells us how the marginal revenue is related to the price and the shape of the demand curve. Because we do have the profit maximizing relationship of marginal revenue equal to marginal cost, when we put this demand information together with the marginal cost, we can actually have a pricing formula for the monopolist. What we have done here is, again, equate marginal revenue to marginal cost and observe that price times 1 plus the inverse of the price elasticity of demand equal to marginal cost. And we divide this 1 plus the inverse of the elasticity onto the right-hand side of this equation. Then we have an expression about the price. Now, the price can be expressed as the marginal cost divided by something. That's 1 plus the inverse of the elasticity of demand. This inverse of elasticity of demand, if you remember, is some number between 0 and minus 1. That makes the whole denominator here some number between 0 and 1. It's a positive number. So marginal cost divided by, say, 0.5. It means the price will be twice of the marginal cost. Or say marginal cost divided by 0.1. Then the price will be 10 times of the marginal cost. So it basically tells us the profit maximizing price that a monopolist can charge will have a markup on top of the marginal cost that cost the monopoly to produce the last unit. That's the marginal cost. They will mark up that marginal cost to charge the buyers when the monopolist maximizing its profit. Still start with this formula. We actually move this denominator back on the left-hand side. P times 1 plus P times the inverse of the elasticity. Then we get the difference between the price and the marginal cost equal to the negative of price times the inverse of the elasticity. And we further divide this price onto the left-hand side of this equation. We get price minus the marginal cost, basically the markup, as a portion of the price divided by P equals the negative of the inverse of the price elasticity of demand. And this is the formula for the Lerner Index. What it says is that this markup is a positive number. Remember, the price elasticity of demand, epsilon here, is negative. Negative sign before a negative number make the whole number positive. So this is a positive number, and the monopolist only supply in the elastic portion of the demand curve. So this epsilon is less than minus 1, which again make the inverse of the elasticity of demand between 0 and 1. That means there is a markup on top of the marginal cost. And this is what the Lerner Index is measuring. The formula for Lerner Index can be certainly viewed as a measure of the price markup, that is, how much the price is set above the marginal cost. Remember that the monopolist is the only firm in the market as a supplier. So the monopolist can set the price, by which we mean that a firm has market power. So the Lerner Index measures a firm's market power. If this markup is higher, the higher the value of the Lerner Index. In addition, this index can be calculated for any firm, not just a firm that is a monopolist. It can be firms in oligopoly or monopolistic competition. Whenever a firm can set its price, whenever the firm is not a price taker, then we say the firm has market power, and we can use the Lerner Index to measure that market power. From what we have seen, based on the monopolist pricing strategy, profit maximizing pricing, the Lerner Index here has a clear economic meaning. It's the negative of the inverse of the price elasticity of demand that the monopolist is facing. So again, because the monopolist is only supplying to the portion on the demand curve that is elastic, which means this epsilon is less than -1, -1 over epsilon will be a number between 0 and 1. First, it's a positive number because we have a minus sign here, and epsilon is negative itself. A negative of a negative number is a positive number. Secondly, because epsilon itself in absolute value is higher than 1, 1 over epsilon in absolute value will be lower than 1, and it's a positive number, so the Lerner index itself for a monopoly will be between 0 and 1. Now let's look at some concrete numerical example. For example, if epsilon is -5, which means the demand curve is highly elastic, the monopoly markup is 20%. It's basically 1 over 5, 0.2, 20%. If epsilon is -2, it's still elastic, not as elastic as -5, the monopoly markup is 50%. That's 1 over 2. It's basically a half, 50%. Let the demand to be perfectly elastic. The epsilon is -infinity. Then the monopoly markup will be 0 because it's 1 divided by an extremely large number. Next, let's look at the economic well-being, or say the social welfare implication of this monopoly pricing. First, if we reinterpret this marginal cost curve as the market supply curve in a perfectly competitive market, then where it meets the demand curve will set the price. So if this is a picture for a perfect competition, then the price will be 16 and the output quantity supplied by the firms in the market will be 8. The consumer surplus will be area A, area B, and area C. In perfect competition, the producer surplus will be area D plus area E. So the total surplus in perfect competition in this picture will be A plus B plus C plus D plus E. However, this is a picture for the monopoly, and the monopoly decide to set the output quantity at 6 and charge $18, and that maximizes the monopolist's profit. Now, because the price is higher, the consumer surplus is only left with A. Producer surplus added this B area, transferred from the consumer surplus. And the producers still have the D area. However, consumers lost C in consumer surplus, and the producer lost E in producer surplus. So in the monopoly market, we have only A, B, D as the total surplus, and the C and E are the deadweight loss. This is very similar to the picture we have seen in Chapter 8, when you have price ceiling or price floor that is effective or binding or a tax, creating a deadweight loss. But here, there's no government intervention. This deadweight loss is created by the monopoly pricing policy. And this is an inefficiency. This inefficiency of monopoly pricing is an example of a market failure. A market failure means that a non-optimal allocation of goods and services such that a market does not achieve full economic efficiency. There is some deadweight loss to the total economic surplus. So that's why we say this is a market failure. This is a monopoly market. It is still part of the market economy. Both sides, the buyers and the sellers, acting for their own interest. Both sides maximizing either utility or profit. But it does not achieve the full economic efficiency, meaning that people in the market still value these goods or services higher than the marginal cost to produce it. And there is deadweight loss to the total economic surplus. Finally, let's look at the concept of natural monopoly. Here, for a firm to establish operation in the market, each firm has to pay a fixed cost of 60. And this fixed cost can be spread over the output quantity. So in the average cost, it's this 60 divided by the output quantity Q. And the marginal cost is constant at $10. What it means is basically that the average variable cost is also this flat marginal cost curve. So let's start with two firms in the market. Each firm will pay this $60 to produce, and then to produce 6 units, the average cost will be 10 plus 60 divided by 6, $20. And this $20 is the same for the two firms, each firm producing 6 units. So when the two firms providing 12 units in total into the market, their average cost is $20 for each unit. However, now consider we only need one firm. Then this $60 can be spread over 12 units. That means for each unit, we only need to add $5 as average fixed cost onto the marginal cost of 10 to produce it. So when you just have one firm paying the fixed cost, we can actually bring down the average cost for producing the same total market output, 12 units, from $20 to $15. That is because we avoided building another factory. Just one factory producing all the output, and spread this fixed cost thinner and thinner over all the quantity produced. So in an industry with a natural monopoly cost structure, having just one firm is the cheapest way to produce any given output level. Governments often use a natural monopoly argument to justify their granting the right to be a monopoly to public utilities, which provide essential goods or services such as water, gas, electric power, or mail delivery.